Hi, this is Miss Guido. Welcome to the Circles Test 1 review video. Make sure you stop and pause the video as needed, rewatch portions that are difficult, and redo the problems. Let's get started. The equation of a circle will be given to you. It's on our SOL formula sheet, and it's x minus h squared plus the quantity y minus k squared is equal to r squared. The center of this circle is at the point h comma k. That point is the center. What I like to remember is that the center is kind of opposite of what it looks like it is in your formula. And the radius is always squared at the end of that equation. Be mindful if they give you the diameter, you need to do half of the diameter in order to find the radius. Let's practice. Our first question gives us the equation of a circle. We want to find the center. The center always has signs that are opposite to what we have in here. So the center of this circle is going to be positive 9, positive 4. That'll be in the first quadrant. The radius is the square root of 36. Square root of 36 is 6. In order to find the diameter, you double the radius, so the diameter will be 12. This question gives us the equation of a circle, and we want to know if these 3 points are inside, outside, or on the circle. They're giving us these coordinates, and we can plug them into our equation for the x and the y values. When I plug in the first point, 9, 10, 9 minus 9 gives us a 0 squared, plus 10 minus 4 is a 6 squared. When I add that together, we get 36 as our answer. Well, that is what the radius squared is in the equation. That means this point lies on the edge of the circle. 10, 5, when we plug that in, 10 minus 9 gives us a 1 squared, plus 5 minus 4 is also a 1 squared. 1 squared plus 1 squared is 2. 2 is a number less than 36, which means that point is inside the circle. When you get numbers less than your r squared, it's inside the circle. And the last one, when I plug in 0, 5, this gives us a negative 9 squared plus 1 squared, which is 81 plus 1, 82. 82 is a number bigger than 36, so that point is outside the circle. Always make sure you plug in your points correctly for x and y and see whether they're less than, equal to, or greater than 36. Question 3 says, write the equation of a circle with the center at negative 10, 4, and a point on the circle is 4, negative 2. I always start off with the center. We're going to plug that center into the equation of a circle. So our equation should say x plus 10, the quantity squared, plus y minus 4, the quantity squared, equals your r squared value. Now, we don't know what our r squared value is, but we do know this extra point on the circle. You can take that point and plug it in for your x and y values, and then solve for your radius. So let's do that. 4 plus 10 squared plus negative 2 minus 4 squared equals r squared. When I do that, I get 14 squared plus a negative 6 squared equals r squared. And when I add those things together, I get 232 is equal to the r squared value. Now at this point, we don't need to take the square root because we need to just plug this r squared value back into our original equation. When I want to see the equation of a circle, it better have variables in it. Those x's and y's need to come back. So we're going to rewrite that red equation at the bottom. X plus 10, the quantity squared, plus y minus 4, the quantity squared, is equal to r squared, which we found out was 232. Question 4 says find the circumference of a circle with an area of 1,809.56 square centimeters. they're starting off talking about area. So that means we're going to first write down the area of a circle formula. Area is equal to pi r squared. Let's plug in some numbers here. We know that 1,809.56 is equal to pi r squared. We want to solve this equation for r, which means we need to divide both sides by pi. Press the pi button in your calculator when you're dividing, and we get that r squared equals 576. In order to undo a square, we're going to square root both sides, and the square root of 576 gives us the radius is 24. If the radius is 24, the diameter is double that, or 48. And in order to find the circumference, we know that circumference is diameter times pi, or 48 pi centimeters. It's always a good idea to put your units on your calculations. Question 5 wants us to find all of the missing arcs in the circle. So let's start off by looking for vertical angles, diameters, anything that will help us. This line, XV, is a diameter of the circle. Diameters of a circle split the circle into two equal halves, each half being 180 degrees. First, I'm going to mark down that vertical angle is 55. So this arc VW will also be 55. Now that I know VW, I can find that XW is 180 minus that 55 that we had. When I subtract, it gives me 125. I only have one other arc missing, that's arc UY. We can look at the top semicircle. We already have 108 degrees and a 55 degrees. Subtract both of those from 180. And that's going to give you that arc is 17 degrees. Now we can start answering some questions. Arc YU is that 17 that we just found. Arc XW is 125. This major arc XVW, that means we're going to start our pencil highlighter at X, go through V, and end at W in red. So we're going to add the 55, the 17, the 108, and the other 55. That gives us 235 degrees. VW we already have labeled is 55. And the final one is YWU. We're going to start at Y, go through W, and end at U. That's everything in this circle except for that 17 degrees. So 360 minus that 17 is 343. Or you could have added 55, 125, 55, and the 108. The next question involves an inscribed angle. Inscribed angles are located on the edge of our circle. We know that the arc is always double the angle. So let's start off. I'm trying to find that that inscribed angle, but I'd need to know what arc JML is. The other two arcs in our circle are already labeled as 55 or 53 and 65, and I can subtract those numbers from 360 in order to get what's left over, which is 242. So this blue arc is 242 degrees, which means that the angle is half of that. 242 divided by 2 gives us 121. In this next problem, we were given that angle R is 30 degrees, and I'm trying to find the measure of angle RPQ. That's this top one. Again, it's always a good idea to see if we can notice any diameters in our circle, which we have. PR is a diameter, which makes arc PR 180 degrees. If I find the angle that creates it, that was angle PQR. It makes an arc that's 180 degrees, so that angle is 90. We can use our triangle rules and know that all of the angles in a triangle add up to 180. So we can take 180, subtract off 90 and 30. It leaves us with a 60-degree angle for angle RPQ. Arc length. Arc length is a formula you are not given on a formula sheet. Here's what you need to remember. Arc length is always just the part of a circle. It's part of your circumference. So the fraction is the degrees out of 360, or that portion of the circle, times your circumference. We know the circumference formula is diameter times pi, or 2 pi r. Good keywords for arc length problems would say the word length, or they would say the word distance. Length and distance are good keywords for arc length problems. Similarly, area of a sector is again just the portion of the area of the circle. That fraction is still degrees over 360. This time we multiply by area of a circle. Again, we know area of a circle is pi r squared. Good keywords here are going to be anything involving area. If you are covering something that is circular, anything with square units, and this would be one piece of pizza, one piece of pie, one piece of something that is circular. Let's practice a few of these. This problem asks us to find the length of arc UT. So here is arc UT. First, we need to figure out the measure, how many degrees it is. I already know we have a 90-degree angle. And now I need to figure out what is missing here. I would need to tell you that, or we would need to see that we have a diameter here. And this diameter is going to make us be able to figure out our missing arcs. If I do 180 minus 27, it gives us that these two arcs are 53. And then we could figure out arc UT by subtracting 180 minus the 90 and the 53. When I do that, arc UT is going to be 37 degrees. That's the measure of the arc. That's how many degrees it is. But I'm trying to find arc length. That's degrees over 360 times circumference, which is diameter times pi. Let's plug in here. Our degrees is 37 over 360 times VS is your diameter. I'm sorry. Yes, VS is the diameter of our circle. So that's going to be multiplied by 12 pi. When you take out your calculators, you're going to follow directions on your test tomorrow and see if it wants you to keep it in terms of pi or not. Let's say we wanted to keep it in terms of pi. We're going to do 37 over 360 times 12. Don't press the pi button. When you do that, you get 1.23 pi. If I wanted you to round it to the nearest tenth, you could then multiply that by pi, and we'd get about 3.87, or to the nearest hundredth would be 3.87. Question 9 says a homeowner wants to build a semicircular patio. If the diameter of the patio is 20 feet, how many square feet will the patio be? Key word in this question is square feet. Square feet is the indication that we are doing an area problem. It's an area of a sector, just half of a circle. So if we are going to follow the degrees over 360, times area, which is pi r squared. If it's a semicircular patio, the degrees is 180 degrees over 360 times pi times our radius would be 10, and we're going to square it. That would give you 50 pi. You also could have found the area of the whole circle and divided it by 2. If we didn't want this in terms of pi, 50 times pi would be about 157.1 feet squared. Square feet because it's an area problem. One more question to go. A circle with radius 12 millimeters is divided into 20 sectors of equal area. What is the area of one sector to the nearest tenth? It's an area problem, so I'm going to start off by finding area of the whole circle. Pi r squared. That'll be pi times 12 squared is 144 pi. I now want to divide that into 20 sectors. So I'm literally going to divide my answer by 20. When I do that, 144 pi divided by 20, we get about 22.6 millimeters squared.